So in this video, we will continue our ongoing discussion of trigonometric functions, and in this video, we'll look at cos x. Cosine function. So let's revisit the unit circle on the coordinate axis. So you have your mutually perpendicular axes, that is xo x dash, xo x dash, and yo y dash, right? These are mutually perpendicular axes. Then you draw a unit circle. Again, what I mean by unit circle is that the radius is 1. So this is equal to 1, this is equal to 1. So a circle of unit radius, right? Now I've said that take any point. What do you do when you want to find the value of sine of the function? Again, for simplicity, I'll restrict it between 90 degrees. Let's say x is restricted between just a moment. X is restricted between 0 and 90 degree. That is in the first quadrant. What is the first quadrant? This is the first quadrant. Now in this quadrant, what you do when you want to find the sine of a function is that you draw an arc. You take an arc. Let's say this. You start at the base, take an arc, and then you rotate it. Then you pick up this tip and you rotate it to the desired value x. So I'll rotate it to some x. So this is x, and then what you do is that you look at this point on the circle and find the coordinates. This y value gives you the sine x, and what is the y value? It is the foot of the perpendicular, right? This AB. AB is equal to sine x. Now what is cos x? Cos x was base upon hypotenuse, which was OB upon OA for this triangle. For triangle OAB, cos x is OB upon OA, which is nothing but the x coordinate. So in a unit circle, the x coordinate gives us the cosine function. So, right, now when you draw the curve for the cosine function in between 0 and 90 degree, you'll observe that at 0 you start with 1 and then you go back to pi by 2. So yeah, just make it much more bit more cleaner. So this is the value of the cosine function between 0 and pi by 2. However, we had expanded. So cosine, okay, or rather so now we have so far we have seen the curve between 0 and pi by 2, right? Now we move on. Now in the last video of sine on unit circle, I've said that there are multiple angles on the unit circle, specifically 4, for which the absolute value or the modulus of the modulus of the cosine function, the modulus of the sine function are equal. So those points that are taken were A, E dash, E double dash, and A triple dash. Right, the coordinates of A were x comma y, those of A dash were minus x y, that of A double dash was minus x minus y, and that of A triple dash was x and minus y, right? So, and inputs obviously x, so this is x, the first input, the second input is actually x dash, then the third input is x triple dash, and so on and so forth. Right. Now, sine of x is equal to x, sine of x dash is equal to minus x, sorry, we are discussing about cosine. So, cos x is x. I'd rather take some different or different variable for the angles. Let this be theta and this be theta dash. Then you have theta double dash, and the last one is theta triple dash. So, cos of theta is x, cos of theta dash is minus x, cos of theta double dash is again minus x, and cos of theta triple dash is x. However, in absolute terms, cos of theta modulus is equal to modulus of cos theta dash, which in turn is equal to modulus of cos theta double dash, which in turn is equal to modulus of cos theta triple dash. So when you expand this cos function to a complete circle, that is between 0 and 2 pi, that is 0 and 360 degree, you get a much more holistic curve. That is, you mark the quadrants, the first quadrant from 0 to pi by 2, the second from pi by 2 to pi, the third from pi to 3 pi by 2, and the last from 3 pi by 2 to 2 pi. You start off with 0 to pi by 2, which we have already seen. It is this half semicircle. From pi by 2 to pi, you have this. From pi to 3 pi by 2, you further get this, and in the last part you have something of this sort. So these are actually semicircles. It's actually my poor drawing skills which make them irregular, but obviously I'll below this video I'll attach the cos function generated on the computer. So yeah, so this is y, this is x. So from x 0 to 2 pi, this seems to be the curve.